Hello everyone, we are a group of three, Mohammad Amin, Biniyam and myself Ahalya Gandikota from Integrated Urban Development and Design at Bauhaus University Weimar. Further to our previous two tasks on water and mobility, we are now here to present to you our proposal for Wurer Edible City, a task as part of our subject Circular Urbanism. Agriculture being the foundation of Ethiopia's economy, accounting to half of its GDP, 83.9% of its exports, and 80% of the total employment, we would like to introduce food as a metabolic factor to the city design. Our main goal throughout the process of the three tasks was to create a dynamic and a self sufficient city contributing to social, economic, and environmental sustainability. To achieve this, we used the concept of creating multiple multifunctional nodes. This helped in maintaining a hierarchy of functions while offering various activities for the self sustenance of the city and for connecting different parts of the city and its users. The primary node, being the urban city center, acts as a commercial and an economic hub with a multimodal mobility hub, a biogas plant, public sanitation unit, and diverse commercial activities. The secondary nodes act as a bridge between the primary and tertiary nodes and allow social gatherings and interaction. They also house a biogas plant and a public sanitation unit. The secondary nodes located near the water bodies can be used as recreational spaces and for public gatherings or festivals. Tertiary nodes are located at the block level. These nodes consist of community gardens, space for livestock, a waste segregation point, storage for crops, and a common well. All these activities and functions mentioned have been provided to ensure social, environmental, and economic sustainability. This shows the interdependence of various functions and facilities. The production of manure from cow dung can be used for grazing and agricultural lands, which are in turn used by livestock or for producing food. This is either sold directly in the market or sent to a processing unit before sending it to the market. The energy generated is either tapped with the use of solar panels or from the biogas plant, which uses the waste from households, agricultural lands, and sanitation unit. Since Ethiopia predominantly sustains on farming, especially in rural areas, we decided to opt for a zero waste model to produce biogas that can be used for cooking, electricity, and other purposes. We used cow dung, household waste, waste from the sanitation unit, and agricultural waste for the production of biogas. Considering an average cow to produce 10 kg of dung per day, it can be seen that for generating 1 cubic meter of biogas, we need 3 cows. This, for example, can generate 2 kilowatt-hour of usable electricity, which is enough to power a 100-watt bulb for 20 hours. For producing the same 1 cubic meter of biogas, we need 1000 kg of household waste, while the amount of agricultural waste differs from crop to crop. The system is designed such that every tertiary node has a waste collection and segregation unit where all the waste from the neighborhood is collected and segregated. This, along with the waste from the sanitation unit in the secondary node, is sent to the biogas unit, also located at the secondary node. The energy generated from this is then distributed to the housing units and the markets and for producing high quality fertilizers for the agricultural lands.
To design a city not only in terms of self-sufficiency for food production, but also walkable and vibrant for commercial and recreational activities, we consider the city growth from the center gradually towards the outer periphery. In the city center, we allocated commercial activities consisting of open market, commodity exchange center, central public space, and multi-mobility space, which will act together as a central commercial hub. Surrounding that, we incorporated residential plots, especially the people for whom are service and job holders working in non-agricultural profession. As we mentioned earlier, we introduced some points of attraction or secondary nodal points with multifunctional public spaces where different types of commercial, recreational, and also processing activities regarding agricultural products will take place. We planned to create good connection among those points by providing both vehicular and pedestrian access so that they will intensify the connectivity of the entire city as destinations of diverse activities. In between these secondary nodes, we are also thinking about some tertiary points consisting neighborhood garden, communal waste collection, and water well. At the outer periphery, we are thinking to accommodate all the plots with single household residences along with their own agricultural lands for mass crop production. In between, we are considering one irrigation network which will be shared by both side agricultural plots. As we have river from both north and south side of the city, the irrigation network can easily be supported from both the side and also will follow the water supply network designed for the newly planned settlement. Within our city, we are thinking about two types of plot arrangement for housing. Type 1 will be multiple housing units with one shared neighborhood garden, shared water well in the middle, and shared other infrastructures both for service and storage purpose for ensuring cost effectiveness. On the other hand, plot arrangement 2 is single households along with their agricultural lands sharing the irrigational canal in between plots. Before going to further planning phases, we tried to analyze and calculate about the existing agricultural lands along with single household residences. After calculating the existing agricultural plots, we came to know that there is roughly 910 hectares of lands available along with 500 existing households in them. Considering 5 persons in each household, there is 2,500 people already existing there. In order to provide more lands for sufficient food production for the city inhabitants, one of our land typology is accommodating community gardens along with multiple housing units within one single plot. Size of each of the provided garden plot is varying from 1 to 3 hectares, where fruits and vegetables are being proposed as probable crop output. On the other hand, we are thinking about probable building footprints, which is more in general as a rough estimation of the probable build form, locations, and their possible pattern in terms of plot enclosure, rather than a detailed calculation of exact building area and footprint. We considered this as a part of future planning scope related to more architectural skill. We estimated a total building footprint area of around 300,000 square meter, considering all the build forms as one-storied and having an average width of 12 meter initially. Among them, probable area for all the housing units is roughly 200,000 square meter, considering average area per household as 200 square meter. So within this, we can roughly accommodate 1,000 households, which is 5,000 people. On the other hand, we considered 1/3 area of these households' footprints as for service infrastructure and storage spaces for different purposes. So in general, there is two major parts in this particular land use, which is community garden and surrounding building footprints. Within this built area footprints, we divided them among housing units area and service infrastructure, which includes shared energy infrastructure, shared spaces for cattle, storages for crops and other stuffs, and shared water well, and so on and so on.
Our design scenario for rural edible city follows a phased or incremental development. We tried to put three prominent phases. Each development phase has distinct values to add and used as a supplement rather than a succession for the previous development. The first phase of the development is about intensification of home gardens, which is mostly discussed in the previous slides. This approach may play a valuable role in initiating communities in the thought of sharing resources and social collectivity. The Southern Nations, Nationalities and Peoples region is known for its high social value. In this phase, we try to use this as a basic input for initiating our development. All the community members are invited to work, live and farm together by sharing resources and amenities. The produced community products are processed in the neighborhood processing units, which are provided in the secondary nodes. New nodes has been introduced, which connects the two riverside recreation centers. On the second phase of the development, provision of the farmland and expansion of forest, agroforestry, irrigation channel, farm fresh market, and cooperative processing units are among the programs The river water will be pumped to the main irrigation channel, which will be provided by the government, and sub-irrigation channels by farmers collectively. The produced products will be brought to the market on site or to the city center. We have located the pump in one edge relatively higher ground so that the water conveyed to the irrigation channel by gravity system. After the farm used the water, the leftover would be discharged again to the river. The farmers have a direct chance to sell their products on the provided farm fresh market. The products which need processing will be transferred to the cooperative processing unit, which then could be brought to the city center market and to the regional market as well. We have provided a nearby agro-processing industry so that the distance from the farm to the market will be reduced. The other approach which is used in this phase is the expansion of forest cover, which already presented in the riverside, by accommodating insect and other cash crops so that it contributes not only to the economy but also to the environmental protection. On the extension of phase 2, the farmland will be expanded to accommodate the new coming farmers, and the expansion of farm market and agro-industry as a result of farmland expansion. The third phase of the development is proposed as a resilience strategy. If the city will attract more inhabitants and want to densify, it can use the existing areas provided for the neighborhood gardens in the city. The displaced neighborhood gardens in turn need space, therefore we provided a space for future expansion, as you can see from the picture on the middle left. The new farmland areas will need the agro-processing industry, and we provided a space right next to it. The farm will use water from the second river on the bottom side of the city to meet its water demand in the summer seasons. When we see the potentials for crop production, according to the Southern Agricultural Research Institute report, the potentials for crop production, especially on the southern regions, are cereals like maize, malt barley, food barley, and wheat, root and tubers like insect and Irish potato, vegetables like carrot, cabbage, onion, and garlic, and even if their share is low, fruits like apple and pineapple, and oil crops like linseed. From all this, insect, maize, and food barley are widely cultivated crops among others. Following the potentials of crop production in the southern region, we have proposed basically three types of products. Product 1, insect and cash crops like coffee and chad, which are located on the expansion area of forest cover, which in turn intensifies agroforestry practices in the region. Insect is a herbaceous multi-purpose crop and a staple food for more than 15 million people in Ethiopia. Insect leaves are a key livestock feed and used as mulch to reduce soil erosion and runoff. Coffee is mainly a cash crop but also consumed. Product 2, crops like maize and wheat, which are located on the farmlands. And product 3, fruits and vegetables, which are allocated on the neighborhood gardening lands. Before allocating areas, we have tried to see the annual share of agricultural products on the southern region. When we see the trend from the 1990 to 2012, coffee and chad had the highest revenue share. Insect and coffee combine together and account for 63% of the crop area in the southern region. As you can observe on the chart, the highest curve is occupied by cash crops and the lowest by annual crops. Even if the cost of teff is higher than kojo or insect, its revenue share is still low when compared to others. The area allocation can take up the trend values and incorporate them in a way they all could contribute to the development of the city. When we see the total farmland allocated area, it takes consideration of existing farmland, which accounts for 900 hectares. To reach up to 2,000 hectares, we still need 1,100 hectares of land. For insect, coffee, and chad, on upper and lower side of the river agroforestry area, We have allocated 250 hectares each, and 500 hectares is allocated for cereals, and the rest 100 hectares for fruits and vegetables. The total farmland allocated will be summed up and give us 2,000 hectares. When we compare the farming share of existing and the proposed one on the existing trend, instead coffee and chat were the highest proportion on the cropland area, and on our new proposal, the proportion of instead coffee and chat is nearly equal to the cropland area. Even if the area provided is higher, the proportion also matters for the effective economical and environmental development of a city. With this overlay of the three phases of the development scenario, we have come to an end of this presentation. We value your constructive comments and questions. Thank you for your attention.